Okay, so once we covered the basic rule of counting permutations, we can move to the third topic of this chapter is combinations. Just a quick recap. The basic rule of counting is talking about how many possibilities you can have for an experiment if you have n different outcomes. And then permutation is a particular practice or application of the rule of counting, or like generalized rule of counting, that when the order matters, just like when you're trying to arrange to 3 different letters A, B, C, we're looking at the number of different arrangements. Combinations is also built up based on the rule of counting, but it's special in the case that the order doesn't matter. So here, remember for permutations, when order matters, there are factorial different orderings of R different items selected. And if you have n items and you only want to select R of them, here we are presenting you a formula for computing the number of combinations. So that's when you have n items and want to only select R of them. And as you can see on the far end, on the right-hand side, the number of combinations you can have is n factorial over n minus R factorial times R factorial. For simplicity, we're going to define a choose function, and we write it as a big, long, tall parenthesis, and we write the number of items n on the top, and then the number of items that you're going to choose R on the bottom. And by definition, the choose function n choose R is n factorial over n minus R factorial times R factorial. So pretty much the choose function that we write over here is giving you the number of combinations if you're going to select R items out of n items. We pronounce it as R, n choose R. And pay attention, you might be asking yourself already, well, what about R? So for example, because you're choosing R objects out of n, so R only makes sense if it is between 0 and 1, between 0 and n, the total number of items you can choose from. So the choose function is defined for this range of values of R, and for any other R values, it's going to be defined to be 0. And also 0 factorial, since you will be working with it when you're trying to use the choose function, and we define 0 factorial to be 1. Let's go through a quick example here. The number of ways to arrange 2 red marbles and two blue marbles. Here, we enumerate all of the possibilities, and you can count there are 6 different ways to arrange them. And if we were to use this combinations formula, we can easily do 4 choose 2. So you might be wondering why we're using any kind of choose function or combinations here. So because you're trying to arrange 2 red marbles and then 2 blue marbles, you can think about that. I'm gonna put 4 marbles into a row, like a sequence of 4 different positions. And in short, I'm really just trying to find how can I choose 2 positions out of this 4 for the 2 red marbles. And once you have chosen those 2 locations, the other 2 positions or locations is going to be left for the blue marbles. So that's why you can think of this as a combination problem, that I have 4 different locations or positions. So that's my n. And I'm just going to try to choose 2 locations or positions out of the 4 for the 2 red marbles. So I can think of R equals to 2. And that's why I can apply the combination formula. And by doing it, you will know that it's going to be 6. Keep in mind that you can think of 4 choose 2 as choosing 2 locations for the 2 red marbles. But at the same time, you can also think of it as choosing the 2 locations for the 2 blue marbles, and you're going to come up with the same answer because 4 choose 2 equals to 4 choose 2. So this is actually a very interesting results that we see later as well, that if you have n choose R, actually will be equal to n choose n minus R. In this case, because you have 4 marbles and R equals to 2, so of course you're going to have 4 choose 2 equals to 4 choose 2. But this is really trying to tell you a different way of thinking about combinations, because you choosing the 2 locations for the red marbles is equivalent to choose the 2 locations for the blue. Okay? So that's why in the end, you're going to have this very general results, which we're going to cover again in a minute. All right, so let's look at this example, exercise for you. How many handshakes take place between a group of 6 people if everyone needs to shake hands with everyone else? This is equivalent to ask how many combinations of 2 numbers are there among 1, 2, 3, 4, 5, 6. So think about why this can be a combinations question, and then of course work it out how you can find out the number of handshakes that needs to take place between a group of 6 people.